In this set of few slides, we're going to talk about what kinds of data. Um, Data mining can be performed on many different kinds of data. In this class, we're going to cover the most frequently seen and widely used, which include relational database, data warehouse, transactional databases. And also a lot of research data data collected through non-data relational database systems. We will cover tidy data next week or the week after, which is basically a tabular data formatted in a way that every row represents one individual. Each column represents a feature or attribute of that individual. That's the typical setup of a data set for a data mining task. Those are the things that we're going to cover in this class. There's many other specialized data types that we're not going to cover, but you should be aware that data streams, sensor data, Internet of Things, those devices generate a huge amount of data, and they all need to be processed. So in this class, our focus, okay, my slides is not forwarding. Please move. Okay, finally. Well, since I can't assume that every student in this class have relational databases knowledge, so I'm going to go over some of the key things that you need to know in order to understand Chapter 4, where we're going to discuss data warehousing. So we need to start to learn what are the key concepts in relational databases in order to understand how our typical relational databases are different or similar to data warehousing. So in our book, they used the all electronics database as example. So a database, this is a database, has a set of tables. So here customer is one table. In this table, we have this number of columns, also called attributes. So those describe a customer, its name, address, age. And we also have a different table item. Those are the things that people can buy. You have item ID, brand name, category, type, price, place made, etc. And also in order to manage employees and different branches, purchase made by customers, items sold. So those are the item, all the items that's in the inventory, and this is items being sold. And employee works at certain branches. So we have earlier introduced the attributes. So those are the attributes in a relational database. Tuples are the individual rows inside a table. So here a customer is a tuple, second customer is a second tuple. Primary keys are those IDs. So for customer ID alone can precisely identify which customer is that. So this is unique identifier that can identify any entry in a table or any tuple in a table. And we also look at some of, for example, works at an employee works at a branch. We can just use employee ID and branch ID to form this connection. Employee works at a branch. Employee is a primary key here, employee, and branch ID is a primary key here, describing the branch, a branch. A branch has a branch ID. And here, by using those primary keys inside this new table, we create a new connection between employee and the branches. Those, well, they are primary keys altogether in this table. It is also foreign key because they each is a primary key at a different table. So those foreign keys create connections among tables. Another example of foreign key, here purchase. In this transaction, this customer purchased something through this employee. So you can see this purchase connects some other tables, transaction table, customer table, and employee table. Those three things, although they form collectively the primary key for purchase table, each of those are also considered the foreign key because they also serves as primary key of a different table. Okay, so that's our basic relational database review. What you need to remember is a database holds many relational tables, and each table holds many tuples, individual customers, individual items, and they are identified using primary keys. And putting primary keys together in one new table, you relate those tables into different relationships. Here, purchase worked at different branches, for example. So relational databases have typical function of data supports database queries and reports. We already mentioned that those are not considered data mining. You can easily use SQL query language to find all customers who have purchased the item under a recall, for example. Those are not considered data mining. However, data mining tasks can certainly be performed using relational database data to discover patterns and trends. Those are data mining tasks. For example, what items sells well in summer seasons? What kind of customers might have high credit risks? So those cannot be achieved by issuing a simple SQL query. You have to analyze the data to identify the patterns. In contrast, relational databases, earlier we also showed that relational databases can be aggregated into data warehouse in our data mining processes slides, right? So in contrast, the data warehouses is a repository of information or data collected from multiple sources, might be multiple relational databases. Every relational database could have a different schema. But once you put the data into the data warehouse, everything is organized under one unified schema. And it's usually residing at one single site. So it's a centralized system. In chapter 4, we're going to look at a few variations, but that's the general concept of data warehouse. Also different from transactional databases, the data warehouse are organized around major subjects. So you might have a customer data warehouse, you have a supplier data warehouse, you have activity data warehouse. Each of those data warehouses answers customer related, supplier related, activity related questions. Those data are aggregated, not like transactional databases. The data may be sales in a quarter, so data is often organized along the temporal aspect and aggregated. So we don't actually care about individual transactions. We don't care whether Hong purchased a pair of glasses. We care how many pair of glasses being purchased during a certain amount of time by what kind of customers. The data is organized into a data cube. So this are different numbers of data cubes. One example is shown here. So here, the top one, you can see this as one data cube. This data cube has multiple dimensions. It has time dimension, item type dimension, and address dimension. So address dimension, you can consider that this as the location of the different branches of this company during different quarters, how many different merchant products has been sold. So for 100, maybe those items, maybe their dollar amounts, it doesn't really matter. But we know that they are multiple dimensions. Because data can be organized along multiple dimensions, and every dimension can have different granularities. We can actually perform very flexible exploratory data mining tasks on a data cube like this. What is illustrated here is a drill down operation and a roll up operation. So in a drill down operation, we can actually bring out more detail of the data. So in this example, we drill down on time for quarter one. So quarter one expanded to January, February, March. So now we can look into every month, the sales data into every month along the item types and addresses dimensions. You can see 400 here is breakdown to 150, 100, and 150. So you get more detailed information. In contrast, you can also roll up. Roll up give you a more aggregated view of the data. So for example, in this example, we rolled up on address. So here address, we have US cities and Canadian cities. When we roll up, we can merge them into US and Canada. Then we have aggregate numbers here. It tells us pattern more clearly. US sale is more than Canadian sale, right? We're going to talk about besides drill down and roll up, there's other OLAP data cube operations that we're going to look in details in chapter 4. So the idea is data warehouse supports multi-dimensional data mining. You can explore along multiple dimensions at a different granularity. So it's a very flexible way of explore what's in the data and try to find patterns. This is part of visual exploration mining approach. So we mentioned earlier data warehouse is aggregation, is aggregated data. We don't get individual transactions. Individual transactions are found in relational databases, and they are also a source for mining. A typical use of transactional data for mining is to do marketing data mining. What items being sold well together? So this is association rule mining. I think we're going to cover this in maybe chapter 6. So this can be applied for the mining. The pattern mined can help the business owners to decide how to shelf items. So the items can be easily found or expose more items for user or for customers to pick up. What small gifts are attractive to people, so you can when you say you give out free gifts on purchases, you can decide what to give away. Those very useful and practical mining tasks. Okay, I think I can stop on the data part. Let's see.